My name is Samantha George, metric number 183443. My final year project is entitled Templating of Bioactive Glass Using Cellulose Nanofibers for Bone Scaffold Application. The project is supervised by Dr. Dayang Radia binti Awang Bia. Introduction. Bone scaffolds are defined as materials that provide mechanical and functional support during bone regeneration. Bioactive glass, BG, is one of the most common synthetic materials that are used in bone scaffolds. Bioactive glass needs to have high porosity so that cell penetration, oxygen and nutrient exchange can occur. Problem statement. A common issue that occurs due to the bone scaffolds is limitation of cell penetration, oxygen and nutrient exchange. One method to prevent the occurrence of this is by incorporation of macro or micro channels within the scaffolds. Since CNF has the highest wettability, roughness and large surface area, it is selected to be a template for the bioactive glass particles. Main objective of this research is to improve the porosity of bioactive glass via templating method. This can be done via synthesizing bioactive glass with salt gel method and synthesizing bioactive glass using cellulose nanofibers as a template. The parameters that are varied are the sintering temperature as well as the ratio of CNF to bioactive glass. For literature review, bioactive glass was discovered by Hench and has been proven to have strong interfacial bonding with the bone. Templating has been used before for fabricating bioactive glass. Properties of nanocomposites, which are high wettability, roughness, surface area, and promote bone regeneration. Method. First objective, the method is to prepare 1 molar of aqueous nitric acid solution. After stirring for 60 minutes, tetraethyl orthosilicate and triethyl phosphate are dropped in, followed by sodium nitrate, calcium nitrate. After a clear homogeneous solution is obtained, the solution is transferred into Teflon container where transformation from salt to gel occurs. Then this gel is aged for 24 hours in an oven at a temperature of 70 degrees Celsius. After that, the gel is dried for 24 hours at 120 degrees Celsius. And finally, it is transformed from gel to glass when it undergoes furnace heating, which is called sintering, to form bioactive glass powder. The effect of the sintering process is evaluated via comparing bioactive glass particles before and after it is heated in the furnace at 750 degrees Celsius. For the second objective, the similar pathway is followed, except that there is an additional step of adding the CNF template just before the clear homogeneous solution is obtained and after the stirring of 45 minutes. Then the steps are followed as per objective 1. For objective 2, the effect of the sintering temperature is evaluated on 5% CNF sample. It was varied between two temperatures of either 550 degrees Celsius or 750 degrees Celsius. As for the effect of CNF content, it was observed by changing the percentage of CNF in the bioactive glass solution by using the formula as shown, and the volume of suspension was calculated. The analyses that were conducted on bioactive glass are in terms of its morphology, chemical properties, crystallinity, composition, as well as porosity. Results and discussion for the first objective, which is effect of sintering on. The samples were prepared, and when they were observed, no observable differences were recorded. First, for the magnification, at 300 magnification, it can be seen that bioactive glass before sintering had agglutination, whereas after the 750 degrees Celsius sintering, it was found that the particles were dispersed. With higher magnification, it can be observed that bioactive glass before sintering is still in gel form, whereas after 750 degrees Celsius, it is more crystalline. Whereas when compared with commercial bioglass, it was found that the particles are less dense compared to bioactive glass that is commercially produced. As for the FTIR analysis, it was found that bioactive glass after sintering at 750 degrees Celsius had the similar chemical properties as the commercial bioactive glass. For the XRD analysis, bioactive glass with 750 degrees Celsius sintering had the highest crystallinity compared to bioactive glass before sintering as well as commercial bioglass. For the second objective, the effect of sintering process, the samples prepared were observed and the bioactive glass before sintering looked more wet. However, there were no detectable differences between the bioactive glass at 550 degrees Celsius and the bioactive glass at 750 degrees Celsius. As for the morphology, at 300 magnification, it can be observed that there were less agglutination with the bioactive glass at 750 degrees Celsius, and whereas at higher magnification, it can be observed that the bioactive glass at 750 had more crystalline surface compared to the bioactive glass that was heated at only 550 degrees Celsius. For the FTIR analysis, it was observed that the bioactive glass that was heated until 750 degrees Celsius had more similar trend of spectrum compared to bioglass at 550 degrees Celsius. For the crystallinity, it was observed that bioactive glass at 750 degrees Celsius sintering temperature had the highest crystallinity compared to bioactive glass before sintering as well as bioactive glass at only 550 degrees Celsius heating. For the second objective, which is the effect of CNF content, observed that the samples prepared had no detectable differences between them. And for the CNF content, it was observed that the bioactive glass at 0 CNF had no CNF architecture, whereas at 5 it was more dispersed, whereas at 10 it seemed to have many bioactive glass particles. Whereas at 15 to 25, there seemed to be a surplus of CNF particles compared to the bioactive glass particles. At closer magnification of 3000, it was observed that the 10% CNF content bioactive glass followed the architecture of the CNF particles, as well as it had the many bioactive glass particles attached to the CNF. Whereas at closer magnification of 15 to 25%, it was observed that there was many CNF particles, and the CNF particles were degraded. As for the FTIR analysis, addition of CNF does not affect the trend of the spectrum, and it had the similar functional groups. For the XRD analysis, it was found that bioactive glass with 10% added CNF had the highest crystallinity. For the EDX analysis, it was observed that pure bioglass and bioglass with added CNF had the same composition, which proves that the addition of CNF does not affect the composition of the bioactive glass. As for the BET analysis, it was found that bioactive glass with 10% CNF added had a 15% higher pore size, which proves that CNF increases the porosity of the molecules. However, bioactive glass with 10% added CNF had lower total surface area compared to pure bioactive glass. This could be due to the macromolecule which is formed when the bioglass is attached to the CNF molecules. Usually, according to literature, specific surface area of bioactive glass produced via sol gel should be around 100 to 300 meters squared per gram. However, this can be explained by the lack of strong acids used, which is there is no hydrofluoric acid used. In conclusion, it was found that the sintering process is necessary for the production of crystalline bioactive glass particles. The optimum sintering temperature for bioactive glass synthesis is 750 degrees Celsius. The best concentration for CNF to be used for templating is 10% by mass of CNF. The addition of CNF does not affect the chemical properties and composition of the bioactive glass, but reduces the average particle size of bioactive glass and increases the pore size by 15%. The templating method using CNF improves the porosity of the bioactive glass particles. For the recommendations, it is recommended that the mechanical strength of bioactive glass with added CNF must be studied to observe how the porosity of bioactive glass affects the mechanical strength of the bone scaffold. In addition to that, in vitro and in vivo studies should be carried out to observe whether we should be carried out to observe the effect of bioactive glass with CNF template. Thank you for your kind attention.